All right, today we want to start talking about descriptive statistics. And it's going to start off pretty easily. It's not real challenging. But so here's the story so far. We're really interested in inferential statistics, really clever. There's some way that we can take a number that describes a little sample, and that number can somehow tell us about a huge group of people, like the entire population of the state of California. Now, that's the fun part of stats, but the other part is something called descriptive. And what our goal in descriptive is to try to help people to see what's going on with a pile of data. In our last lecture, we talked about how to sort that data. We need to understand whether we're dealing with categorical data, which is words, or whether we're dealing with quantitative data, which is numbers. So here's kind of the story of where we're going today. Years and years ago, I worked at KinderCare, and if you're not familiar with that, that's a preschool for young children. So I worked there one summer. It was crazy hard, so that was the end of that. But at the end of the day, I'm sure as you can imagine, if you go to KinderCare, go to a preschool, at the end of the day, there were toys all over the floor. So before you leave, the kids are all gone. What you have to do is you have to tidy things up. But imagine that I was there at this preschool at the end of the day, and I wanted to describe to somebody what kind of toys that we have. Well, you could pick up a Barbie doll, say, so someone's on the other end of the phone or whatever, you say, I have a Barbie doll. I have a Hot Wheels car. I have a train. I have an action figure. Oh, here's another Barbie doll. Here's another Hot Wheels car. Here's a pair of scissors. That would not help the person in any way. They would have no understanding of what you've done. You haven't described it for them in a way that's at all helpful. I mean, you did it, but that's not going to help them very much. So what we do instead, what we did at KinderCare, the first place to start is we would have bins. If I can get my, there we go. I don't know if you've ever seen a toy box that has a couple of shelves. You ever seen a toy box like this? These are the bins. You got another row. So what you would do, these are open tops. What you would do is you'd go around the room and you pick up all of the Barbie dolls and you put them in a bin. And then I go around the room and I pick up all the Hot Wheel cars and I put them in another bin. And then I pick up all the scissors right there. And then I pick up all the action figures and all the coloring books. And I put everything in a separate bin. So if you want to describe this situation to somebody, the place to start is you need to clean up. You need to put everything in the bin in which it belongs. So we're looking at categorical today. So the answer is words. Somebody says, what's the toy situation like at the preschool? Well, we've got Hot Wheels cars, we've got Barbie dolls, we've got scissors, we've got this, but first of all, we want to clean them up and put them in a table called a frequency distribution. So now this is a bunch of different colors. I might say, what's your favorite color? But in my illustration, this is all the toys. Barbie dolls, Hot Wheel cars, toy trains, action figures. You put them all into their bins. Here's our bins. You see, I've cleaned up. I have everything cleaned up and put in its proper place. Well, this is categorical data. So I can tell them that, but I want them to get a picture of what's going on. So the very first thing I do is after I've cleaned up, I count them. I've got 3 Barbie dolls. I've got 5 Hot Wheels cars. I've got 3 trains, whatever. So I clean up and I count up how many of everything that I have. That's a great place to start so that people could get an understanding of what kind of toys are in this room. So we clean up, we put it in a frequency distribution. This is called a frequency table. And we just count up how many of all the different things we have. It could be colors. In my story, it's toys. Now, there's not a lot you can do with categorical data. But do you see I could help people maybe get a better picture if I turned it into something called relative frequency? And relative just means in relationship to all the other toys. So again, this says yellow, blue, green all the way down here. I wish it said the toy names. I should change this. But so relative to the other toys, what I could do is turn this into percents. I've got 3 out of, I don't know how many I got here. Let's say it's 8, 11, 7. Yeah, I got 20. So 3 out of 20 toys is 15% or 0.15. So I'm just turning my counts into percentages. And don't you see that would help somebody get a better understanding? They could maybe visualize the toys in the room a little better. 15% of the toys are Barbie dolls. 25% are action figures, whatever. So I put everything in its basket. I count them up. And if I wanted to, I might be able to help people understand a little better if I turned it into a percentage. Now, this is going to be a big deal later, and it's not going to make a whole lot of sense on its value right now. But there's also another way I could help people see it called a cumulative relative frequency. And all this does is it takes our relative frequency and it just keeps adding it as we go. You see, 15 here is our first one. 4.4 are these 2 added together. 0.55 are these 3 added together. It keeps accumulating. It keeps adding together where you're at and all the ones down. So the 0.85 is this one and all of these. The 0.95 is this one and all of these. And then eventually, if you see where this is going, the last one has always got to be 100%. It's got to be this one plus all the others. So again, not super important now, but it'll become more important later. So we clean up the toys. What we could do to help people understand better is we could count them. And we could turn them into a percent. Now, there's one step better. If you're familiar with the expression, a picture is worth 1,000 words, I could tell someone all I have about the toys that I picked up off the floor. I could tell them all about it. And that would be helpful. But there's an even faster way that I could help someone get an understanding of the toys. What I could do is I could turn it into a picture. And this matters. So for categorical, there are only 2 kinds of pictures that we're interested in. Okay, we're going to do quantitative on Thursday, and there are different kinds of pictures, graphs that we're going to turn this into. But for categorical, you've only got 2 choices. For us, you're going to do a bar chart or a pie chart. A bar chart is just what you think. Here are my different baskets. Like this would say Barbie dolls. This is cars. And it just tells you each of them and how many you have in each of the baskets. So bar chart. It's really important to notice that there's gaps between these. We'll talk more about that later. But if you make a bar chart for me, I do not want them to touch each other. These are categorical data, and they're not really connected down here, okay? So I want to describe for people what's going on with the toys in the room. Let's turn it into a picture. And one easy way to do that is a bar chart. The other one, well, real quickly, I'm sorry, this is a bar chart called a Pareto. And a Pareto is just a bar chart that just goes from the highest number down to the least. So if we had the most Barbie dolls, this would be the first one. If the next most was cars, the next most was action figures, we would go down the line, okay? Goes tallest to shortest. This is an obvious one too. This is side by side. Suppose we wanted to compare the toys in one room to the toys in another, or in this case, full-time people to part-time. We're just putting 2 of them right next to each other so we can get a picture. Okay, so here's our last one. It's a pie chart. This one, what we've done is we've turned those relative frequencies into slices of pie. Each of these represent the proportion. So suppose Barbie dolls had been 75% or whatever. Well, this wouldn't be 75%. Let's call this 70%. We try to make the slice of the pie to be the correct percentage. And then this one looks like about 10%. We try to match these up. Maybe this is 8%. This isn't going to work. My numbers don't work out. Let's say that's 20. And this is 2%. So our slices of the pie should represent the percentages. Now, why are we doing this? Again, it's because a picture represents 1,000 words. I'm trying to describe to you the toys that are in this room. I can clean them up. I can count them up. I can turn them into percentages. But if I really want to help you see, you can see a glimpse in one picture. Look, there's a picture that immediately helps you understand how many of the different kinds of toys we have, or the stat students. So we've got two kinds of categorical, or if we have categorical, we have two ways that we can turn it into a picture. We can do it with bar charts or pie charts.